Okay, children. Today we will be discussing the problems of chapter 12, atoms. In a first one, in a GJR Marsden experiment, calculate energy of alpha particle whose distance of closest approach to the nucleus of Z equal to 79 is 2.8 Newton raised to minus 14 meter. How will the distance of the closest approach be affected when the kinetic energy of the alpha particle is doubled? So first you have to read the question well and write what all quantities are given. And you have to find out, connect it with the equations. So first let us see what is given here. Distance of closest approach. Calculate energy of alpha. First you have to calculate energy. And whose distance of closest approach to the nucleus of Z. Z is given, atomic number is given. And the distance of closest approach R0 is also given, 2.8 into 10 raised to minus 14 meter. How will the distance of closest approach be affected? So you should know the formula for that, distance of closest approach and energy relation. So we know energy equal to 1 by 4 epsilon 0 Zg 2E by R0. Then from that E can be calculated. Substitute all the values. E means charge of protons are inside the nucleus. That is 1.6 into 10 raised to minus 90. Z is the atomic number. So substitute that in the formula and calculate the answer, which is found to be 1.300 into 10 raised to minus 12 joule. We get the answer in SI system joule. Suppose we want to convert that into million electron volt, you have to divide that by 1.6 into 10 raised to minus 30. If you want to convert that into simply electron volt, we have to divide with 1.6 into 10 raised to minus, it will be minus 90, minus 90. Electron volt minus 90. Million electron volt, it will be, you have to divide it with the answer with 1.6 into 10 raised to minus 30. Okay, so we get the answer in MeV, million electron volt. Then as E is doubled, what happened to R0? And from the formula we can see. E is doubled. See, when it R0 is taken to here, and E will come to the denominator. R0 you take here, and E will be here. So when E is doubled, what happened to R0? It will be half. So for example, 2E, it becomes 2E. So the answer divided by 2 it becomes. So it is half. Okay. The energy level diagram of an element is given here. Which transition corresponds to the emission of a spectral line of wavelength 102.7 nanometer? It's an important question. Energy level diagrams are given. See, ground state energy minus 13.6, then minus 3.4, then minus 1.5 eV, then minus 0.85 eV. And different transition A, B, C, D are given. And what is given in the question? The energy level diagram of an element is given here, which transition corresponds to the emission of spectral line of wavelength 102.7 nanometers. So wavelength of the line emitted when a transition takes place, radiations are emitted. These radiations are having wavelength, and emitted wavelength of the radiation is given 102.7. So corresponding to that wavelength, what's the energy that you have to find out? So let us find out the energy corresponding to that wavelength. 102.7 nanometer changed into meter. How into 10 raised to minus 9. So lambda equal to 102.7 nanometer. Change that into meter, multiplying by 10 raised to minus 9. Okay. Then energy emitted corresponding to the energy E equals Hc by lambda. H we know 6.6 into 10 raised to minus 34 into C is 3 into 10 raised to 8 by lambda 102.7 into 10 raised to minus 9. So doing the calculation, we get the answer 1.935 into 10 raised to minus 18 joules. We are getting the energy in joule. Usually, energy of this radiation and all is expressed in electron volt. That's why we are converting that into electron volt. And also one more thing, the energy level diagram, energies are given in an electron volt. So our energy also should be converted into electron volt. Then only we can calculate that corresponding to which transmission this energy comes. So we just convert that into electron volt dividing by 1.6 into 10 raised to minus 90. So we get 12.1 eV is the energy we are getting. So you just look at the diagram. Just look at the diagram. Look at the diagram. Which transmission gives 12.1 eV? So this is the ground state energy minus 13.6. So when an electron jumps from higher energy level to this level, that difference in energy is 12 points. So no transmission will give 12 points. See, from this to this, see there is no 12 coming, minus 1.5, minus 8.5, minus this will never come 12. And this also you see there is no but 12 here or more than that. But only here you get this transition only you can see 12 coming. 12. When we find the difference, that means higher energy level will have more energy. So minus 1.5 minus 13.6 minus 1.5 minus 13.6 eV is the corresponding energy turn when the electron jumps from this level to this level. So we got it 12.5. That is its transition D. This is D. This is D. This is D is marked. You have to mark D here. So the transition D is corresponding to this length emission, the length of the emitter radiation. So like that you have to find out. Next question. In the ground state of hydrogen atom, its Bohr radius is 5.3 into 10 raised to minus 11 meter. The atom is excited such that the radius becomes 12.2 into 10 raised to minus 11 meter. Find the value of the principal quantum number and total energy of the atom in the excited state. So first Bohr radius is given R1 5.3 into 10 raised to minus 11 meter. That means the ground state N1 equal to 1. And then the atom is excited that the radius becomes 2, G1.2 raised to 11. So that we can take R2, G1.2 into 10 raised to minus 1 meter. And which number, the quantum principal quantum number, that we don't know. Ground state energy is given, which is excited and which we don't know to which level it is excited. So N2 we have to put question mark. And energy also we don't know. Find the value of the principal quantum number and total energy of the atom in excited state. What is given? And R2, R1 are given. N1 also is given. So there is a relation connecting radius and then R is proportional to N square. So R2 by R1 and 2 by N1 whole square. R2 is proportional to R is proportional to N square. So R2 will be proportional to N2 square. R1 will be proportional to N1 square. So R2 by R1 will be equal to N2 square by N1 square. So you just write the values and if from that you can find out N2. This is N2 by N1 whole square is 4. So what is N2 by N1? 2. So what is N2? 2 N1. So that's equal to 2 into 1. N1 is 1. 2. So N2 we got, it is first excited state. Ground state is 13, minus 13.6. N equal to 1. Then N equal to 2. Here we got N2. First excited state means N principal quantum number. N is equal to 2. First excited state now, n equal to 2. So E2 energy in that state, E2 is equal to radius is R2. That's the energy E1 by N1 N square. E1 by N square. So first ground state energy minus 13.6 by 2 square. So we get the answer. The ground state energy of hydrogen atom is minus 13.6 eV. If an electron makes a transition from an energy level minus 8.5 eV to minus 3.4 eV, calculate the wavelength of the spectral line emitted. It's also an important question. To which series hydrogen spectrum does the wavelength belong? So here the energy transition is taking place. Ground state energy is given. N equal to 1 energy E1 equal to minus 13.6 eV. And electron makes the transition from an energy level, higher level to this minus 8.5 eV to minus 3.5 eV. So what is the energy difference? E2 minus E1 minus 8.5 minus 3.4 minus 8.85 plus 3.4 eV. That difference you have to find out. And you will get that. See, energy E1 minus E2 equal to minus 0.85 minus 3.4. That is 2.55 eV. Just convert into joules and corresponding wavelength you can find out. Hc by lambda, h nu equal to hc by lambda equal to E1 minus E2. Then lambda equal to h into c by this one. This is energy difference. So h nu equal to hc by lambda equal to E1 minus E2. E1 minus E2 we got this value. In joules it is this value. So if you want to convert into electron volt, divide this by. So this is in electron volt. So electron volt energy is coming into 1.610 minus 19 will be the answer in joules. Then from that lambda is calculated. Lambda it will get c by this value. Substituting we get the answer. Wavelength we get 4,852 angstrom. We know 4,000 angstrom to 7,000 angstrom, it is visible spectra. So this wavelength belongs to the visible region of the hydrogen. So for that you should know the range of visible spectrum. 4,000 angstrom to 7,000 angstrom, it is the visible spectrum. What is the ratio of the radii orbit corresponding to the first excited state and the ground state in hydrogen atom? Same type we have done one question, R2 by R1 equal to N2 square by N1 square. So 2 square by first excited state to the ground state. First excited state means 2 square, N2 equal to 2. Ground state means N1 equal to 1. 2 square by 1 equal to 4. The ground state energy of hydrogen atom is minus 13.6 eV. What are the potential and kinetic energy? So this energy of an electron in electron Bohr orbit we have already calculated, minus 13.6 eV. What is the relation connecting potential energy and kinetic energy? That is very important. I usually ask as a 1 mark question because directly you don't need of calculation and all. If ground state energy is given, that's the total energy. So you can write total energy equal to minus 13.6 eV. What are the potential and kinetic energy? So kinetic energy is negative of total energy. Very easy. Just negative of this one. That will be plus 13.6 eV. So total energy is given. How will you find kinetic energy? It's a negative of total energy. Because kinetic energy we know it's always positive. Kinetic energy is always positive. So minus of total energy is kinetic energy. Then potential energy, how will you find? If you know kinetic energy, you just multiply with kinetic energy, we know that is positive. And potential energy, here it is an attractive force. So it is negative. Potential energy is minus of 2 into kinetic energy. Minus of 2 into, so potential energy is negative, total energy negative, but kinetic energy is positive. So 2 times the kinetic energy will give, 2 times the kinetic energy will give potential energy. Potential energy is negative. So in electron volt we are getting that. The next energy level diagram. The energy level diagram of an atom are shown in figure, which transition correspond to the emission of radiation of maximum wavelength, minimum wavelength. Maximum wavelength means energy will be minimum. We equal to hc by lambda, energy and lambda are inversely proportional. So maximum wavelength is asked, you have to find minimum energy. Minimum energy means the shortest length. See, when we find the difference, which difference is giving the minimum value, that transition will be the maximum wavelength. So maximum wavelength is also from this diagram, you can tell this is the longest one. And the energy difference also will be more. 10 minus 10 minus 2 minus 10 minus 2 plus 10, that will be 8 eV. So that is the maximum energy transmission, maximum energy. So that will be the minimum wavelength, So maximum wavelength means minimum energy. This will be minimum energy. So as energy emitted is hc by lambda, it is inversely proportional to wavelength. For maximum wavelength, E should be minimum. Transition A, minimum. Transition A, for which energy difference E is minimum, correspond to the emission of radiation of maximum wavelength. Similarly, transition D, for which energy difference is maximum, correspond to the emission of radiation of minimum wavelength. The energy of electron in ground state of hydrogen atom is minus 13.6 eV. How much energy is required to take an electron in this atom from the ground state to the first excited state? So first write energy in the ground state minus 13.6 eV. Energy in the first excited state n equal to 2. You have to type 8 minus 13.26 by 2 square. So that is minus 3.4. Then what is asked, how much energy is required to take an electron in this atom from the ground state to the first excited state. So find the difference. First excited state is having more energy, minus 3.4 minus 13.6. That's equal to 10.2 eV. So that much energy is required for the electron to jump from ground state energy to the first excited state. Next, the ground state energy of hydrogen atom is minus 13.6 eV. If the electron jump to the ground state from the third excited state, third excited means n equal to third excited state, you have to take n equal to 4. Third excited n equal to 4, you have to take. First excited state n equal to 1. Second excited state n equal to 2. Third excited, first excited ground, for example, ground state n equal to 1. First excited means n equal to 2. Second excited state n equal to 3. Third excited state n equal to 4. We will have to remember that. Third excited state n equal to 4. So energy in that orbit will be minus 13.6 by 4 square. That's equal to minus 0.85 eV. So what is the energy emitted? E4 minus E1. H nu equal to 12.7 eV. Therefore, nu equal to this divided by h. And here, SI system, you want to see the answer. So electron volt, you have to convert into joules. Then you will get the answer in hertz frequency. What is the shortest wavelength present in the Paschen series of spectral lines? Shortest wavelength means energy will be maximum. Energy transition maximum from, that is when, see, this is the series Rydberg formula we know, H2, E2 minus E1, that is equal to Hc by lambda, Hnu equal to Hc by lambda, equal to Rydberg constant into 1 by n1 square minus 1 by n2 square. n1 in which series? Paschen series, n1 equal to 3. So this constant's value substituted here, and it is multiplied with 1.6 minus 19 to get the answer in SI system. Then see wavelength, which wavelength? Shortest wavelength. So shortest wavelength is highest energy. For energy, highest energy we get from infinity to third level. Electron jump from infinity to third level. We get the maximum energy but minimum wavelength. So infinity you have to put here, shortest wavelength. If it is maximum wavelength, which will you give? N2. N2 equal to 4 you have to have. N1 is 3, that is a constant value. But N2, shortest wavelength, N2 you give infinity. But the longest wavelength, N2 you have to give 4, just next number. 4 you have to give. Okay. Then you have to do the calculation to get the answer in meter. So here it is written in nanometer. The difference of 2.3 eV separates two energy levels in an atom. What is the frequency of radiation emitted when the atom transits from upper level to the lower level? E equal to 2.3 eV, that is converted into joules. E equal to h nu, nu equal to E by h. Nu is calculated.